Hi there, and welcome back to the road to ProveIt 2026. My name is Christopher Sandoval, and I'm a developer relations advocate here at FlowFuse. Now, for the past few weeks, we've been preparing our demonstration for ProveIt, the flagship industrial automation event that's happening in Dallas, Texas. We're so close to the event, and I'm super excited to show you everything that we built for ProveIt 2026. But before I show you the final build and the supportive structure that it deploys, I want to show you how we intend to use this demo in the future. And specifically, I want to show you how we future-proofed it for future iteration and expansion. Today on the road to ProveIt, building for the long term. Let's dive right in. So when you're creating systems really of any size, it's super easy to get locked in on scope. You may have to build something for a specific utility or a specific purpose, but it's really easy to get tunnel vision if you get bogged down in scoping just for that project. The reality is that your system may be used for years to come, and accordingly, you need to build for maintenance, extensibility, and scalability. For our demonstration, we kept everything super modular. We're using two Rios, one for the mixing station and one for the packing station. And then that data is being pushed via MQTT and OPC UA. These machines are basically operating as machine centers, and then they're pushing to a single source of truth that can be referenced throughout the system. Now, in order to make this as usable as possible, we had to give some thought to the structure of the data that we're pushing. Essentially, we've broken this structure down into a cohesive namespace. We have enterprise, site, process area, cell, and then asset. By tagging this process accordingly, when we want to expand this out in the future, we can add units quickly and understand at a glance how they work with each other. And speaking of wiring things up, I do want to briefly talk about documentation. You'll see in our demonstration that everything is clearly labeled, allowing anyone to understand exactly what's going on, where it goes, and in what order. Now, this is obviously a bit chaotic right now, as this is not wired into place because this is just a workbench, and you certainly don't have to go into this much detail in every single build, but an ounce of documentation pays off huge in the long term. Generating circuit diagrams, wiring guides, and documentation around your build process might seem like an extra and annoying step, but when you have to fix something 5 years from now, or more likely when something breaks when you're sleeping and someone on site has to fix it, having this material on hand will make a world of difference. Another point that I'd like to make here is that you should be meticulous in your process and kind in your execution. What I mean by that is that this work has to be really process-oriented. When you're building out an installation of any size, you should be really meticulous in how you go about the process of deploying that system. When you're stripping wires, you should make your best effort to make sure that they're roughly even. When you're wiring harnesses, you should have a wiring guide that you're providing to other future users. You should follow that guide really closely, and you should triple check your work. Since a miswired lead could mean bizarre behavior that you have to spend hours to troubleshoot, making sure that you're actually building these things properly and then documenting that build process is going to save you a ton of time and effort. The idea here is to make sure that your execution is as clean as possible to remove any possibility that it was your execution that was the problem and not the core process. But beyond that, you should also be kind to yourself and to other people working on the system. Small things like wrapping wire in a sheath or even wrapping a piece of tape around it is going to make this system much better to work on. If you're doing soldering, make sure that you remove extra flux. If you're attaching systems, make sure that screws and bolts are tight in the specification and not literally as tight as you can get them. If you're using flags for your wiring harness like I have, then make sure that the flags are a little bit back from the end of the wire. That way, when you're wiring the system up, you can actually see where the wire is going to and you're not obstructed by all of the flags. These small steps will go a long way towards making your system maintainable, but it'll also make it scalable and extensible, as people won't mind working on this machine and duplicating it to additional units. And finally, as part of your documentation, document what the system should be doing. This might seem like an obvious step, but the reality is that if something is broken, we're not going to know that it's broken unless we know what it should look like. So model your best case scenario, test it on paper and apply it in theory. And then once you actually deploy, validate what you're doing against that source of truth. If you know that you have to publish to MQTT and you know that it has to have a specific structure, then when you deploy it on site, see if you actually match that structure. This all might seem obvious, but a lot of people go into constructing these systems thinking that they know what the end state looks like, only to discover halfway through that their end state isn't actually what they want it to do. So make sure that you actually know what good looks like. So to summarize, when you're embarking on a project like this, all of this can be broken down into a handful of best practices. 1. Keep systems modular. If you don't bite off more than you can chew, then each unit is going to be maintainable, extensible, and scalable. 2. Adopt a unified structure. Your system data should define itself to anyone looking at it, so keep it sensible and consistent. 3. Document everything. Documentation is the best way to connect your thoughts and processes to future operators and engineers. 4. Be meticulous. Triple check everything. If you think that a harness or wire run looks perfect, you should probably check it one more time. 5. Be kind. Don't focus on just getting things done. Take care of yourself and your fellow operators and engineers and clean up your work. 6. Identify what good looks like. You won't know something is broken unless you know what it should look like when it's not. So identify what operational success looks like for each unit, process, and machine. We're almost ready to break down the server and ship it off, which means I'm also ready to get on the plane to head to Dallas. If you'd like to check us out in person at ProveIt, you can find us in booth number 17. If you'd like to see our CEO's presentation, you can see him on the Litmus stage at 3:15 p.m. on Tuesday, February 17th. And finally, if you'd like to connect with me and do a workshop on FlowFuse, MCP, and AI, we'll be doing a workshop on Wednesday, February 18th at 4:30 p.m. You can check the description below for links to all of those events, and we hope to see you there. But we're not done with the road to ProveIt. So check back next week as we dive into the on-site installation and demonstration at ProveIt. This has been Christopher Sandoval, thanks for watching, and I'll see you next time.